we need to make some decisions. Okay, we were able to get the data, we are also able to process the data, but now we need to make some decisions using this data. Okay, because at the end of the day, we need to, you are going to act like a calculator, you are the calculator. What data you have to get from the user is you need to get numbers basically. Okay, after getting the number, you have to process the number, and next decision what you need to make is whether to display the data or you need to display something else. Okay, so those decisions should be made, and in order to make decisions as such, there are plenty of ways to do it, but we are going to explore in LabVIEW on how to make these decisions. Okay, so in order to make these decisions or other things, we have a certain objects in LabVIEW called as structures. Okay, so we are going to explore what the structures are. So there are many types of structures available in LabVIEW. So let us explore them one by one. Fine. So before going into structures, let us explore about what is decision making. Okay, so decision making is to make some uh, just to analyze some statements and act on those statements, right? So for example, let's say we are going to monitor a boiler. Okay, right now if you want to monitor a boiler, we know that we are going to use a thermometer there, and just monitoring is going to be a problem. It's not going to be an issue. Okay, it's going to just show you the temperature value. But tomorrow, let's say you want to make some decision based on the temperature. In that case, there you have to make some decisions. Okay, so in that case, there should be a way where you can compare some values. Okay, and based on the value, you can, based on the comparison, you need to do some processing. Okay, so that things will become a little bit vague, right? So
డాడీ
we need to explore how we can do
సాయి
that.
బాల్ పరాటా
So in
కొడితే
order
నాకు
to do all these things, there are plenty of functions which are available in
ఏం బా
LabVIEW.
నాకు కావాలి ఏ
Okay, plenty
జాన్
of
రెండు తిన్నాడు ఒకటి
objects which are
తెమ్మంటే
available in LabVIEW.
అయిపోతున్నావు.
So let us see by example. Okay, so let's say I have a thermometer which is actually connected to a boiler. Right now, if I want to, let's say, um, I want to emulate this as a boiler thermometer, and when the temperature crosses certain value, okay, I should indicate some sort of uh, indication. Okay, because control and indicator, right? We need to find a way to emulate certain things. So how we can do that? You can find a way to change this to a mode, okay, where this can be made as a emulation value. Okay, but right now if you see,
అవి
my thermometer
ఏమంటుకోదు
is an
కవర్
indicator.
ఇట్టేను.
Okay, how I can say it's an indicator is when you see a block diagram, the arrow mark of it is going to be in the left hand side. Okay, but right now if you want to control it, it should be a control, right? So what I'll do is, again, this is a golden rule. You can actually convert a control to an indicator, or you can convert an indicator to a control. Any control can be converted to indicator, any indicator can be converted to control by simply right click on it, and you have an option to change to a control, or if it's a control, it will be changed to an indicator. If you right click and change to a control, right now you can see in the block diagram the arrow mark changed from left hand side to right hand side. So right now we have found a way to acquire data from the external world, but now we have to make some decisions. In order to make some decisions, you need to make some comparisons. Okay, so to make comparisons, you need to have some certain set of functions, right? So yes, we have certain functions called as comparison functions as well. Okay, so these are going to help you make some very interesting comparisons. Like instead of rendering the syntax for this comparison, you have the comparison function here itself. Okay, like equal to, not equal to, less than. Okay, let's say I want to check whether it's done. Now I want to make some decision. Before making the decision, I have to check the condition, right? So what I'll do is I can make use of any of the comparison functions here. But let's say I want to check, I want to design a boiler monitoring system where I'll have a way to check if the temperature goes above certain value. Then in the future, I can act like I can switch off the boiler, or if the boiler data is off, I can make it switch on. Okay, something like that. So what I'll do is I'll check to check whether the boiler value is greater. I can use a function called greater than function.
సైబాల్
Okay, I have
పరాటా
greater than
కూడా
equal to less than equal to 20. So what I'll do is I'll just use the greater than function. And here you can see that I have an input like this. So what I can do is I can check the temperature value is greater than another input value. Okay, this compares both of them. And this value can be a control or a constant or whatever you feel like. Okay, right now I right click, create a constant. And let's say this boiler is going to be holding water, and in a simple temperature set in the boiler setting, and water is not normally heated 100 degrees Celsius. Okay, inside the boiler the water will be superheated. Okay, so if it is superheated, surely it will exceed 100, and surely it will exceed 200 degrees Celsius. So what I'll do is I'll set the danger as, let's say, 250 degrees Celsius or 225 degrees Celsius. Okay, when it exceeds this value, it's going to be a problem. And whenever you compare something, you can say only it's true or false, at least currently, right? So in order to emulate the true or false, the output should be a boolean. Okay, that's why if you see the comparing function is going to have boolean. So here I have a boolean indicator, and I can connect the output of this to boolean indicator. And right now if you see this boiler, right now it's going about 225, and right now if you see this thermometer can only measure up to 0 to 100. That's going to be a problem. Rather what I can do is I can change the thermometer output to 300. This thermometer can measure up to 300, okay, but your boiler may not be able to handle those things, okay, because whenever you have something which can handle up to certain limit, the measurement system should be able to handle much more, right? Only then this will have a way to check if the temperature goes above certain value. Then in the future, I can act like I can switch off the boiler, or if the boiler data is off, I can make it switch on. Okay, something like that. So what I'll do is I'll check to check whether the boiler value is greater. I can use a function called greater than function. Okay, I have greater than equal to, less than equal to 20. So what I'll do is I'll just use the greater than function, and here you can see that I have an input like this. So what I can do is I can check the temperature value is greater than another input value. Okay, this compares both of them. And this value can be a control or a constant or whatever you feel like. Okay, right now I right click, create a
बर्नल का
constant.
सैबाल ते
And let's say this boiler is going to be holding water, and in a simple temperature set in the boiler setting, and water is not normally heated 100 degrees Celsius. Okay, inside the boiler the water will be superheated. Okay, so if it is superheated, surely it will exceed 100, and surely it will exceed 200 degrees Celsius. So what I'll do is I'll set the danger as, let's say, 250 degrees Celsius or 225 degrees Celsius. Okay, when it exceeds this value, it's going to be a problem. And whenever you compare something, you can say only it's true or false, at least
Daddy,
currently, right?
Paratha,
So in order to emulate the true or false,
cyborg,
the output should be a
cold
boolean.
egg.
Okay, that's why if you see the comparing function is going to have boolean.
కాటన్ కొడితే
So here I have
డాడీ
a boolean indicator,
లేదు
and I can connect the output of this to boolean indicator.
ఈ పరాటా
And right now if you see this boiler, right now it's going
అమ్మ
about
కూడా
225, and right now if you see this thermometer can only measure up to 0 to 100. That's going to be a problem. Rather what I can do is I can change the thermometer output to 300. This thermometer can measure up to 300, okay, but your boiler may not be able to handle those things, okay, because whenever you have something which can handle up to certain limit, the measurement system should be able to handle much more, right? Only then this understandable. So you can see that when I try to increase the value of the boiler thermometer, nothing happens. Okay, until 200 and will not happen, anything happen. But once it exceeds the 225, your boiler gives you, the comparison function gives you a true data. Right? So it's very easy for us to create a virtual machine for this to check whether the boiler is going to explode or not. Right?
తే
So this is how you can make some decisions. Okay, right now this condition function will help you make decisions, but right now still we are not making decisions. Okay, that we'll do step by step. Okay, so this boiler, right now if it exceeds certain value, this may be danger. Okay, but also there are certain boilers which will not work under certain temperature. Okay, so you may also need to check whether the temperature is less than. Okay, so I'll have function called less than function somewhere, and typically what you'll do is you connect from here to here, but sometimes this connection is made automatically in normal previously, so it will not be easy for us to make the connection. So in that case, what you can do is you can always go from reverse also, from this terminal to this wire. This will be junction. Okay, so what you can do is boiler value is less than, let's say your boiler may not work less than 30 degrees, or let's say in the cold region less than 20, your boiler may not start on. So for that you can have one more LED. So when it goes below 20, you can see this cold is also happening. Right? So now I said for both of them, color is going to be the same. Okay, and since we all say that lab is a graphical programming language, okay, it should be having ways to change certain colors. Okay, GUI means it should be able to alter those as well. So there's also a way to do that. You can always right click on control indicator and you allow something called properties. Okay, you can always access the properties of your control indicator by right clicking on it. And first property is property with appearance. Okay, so when you say danger, it's possible that it should be the color on color should be red in color, and off color can be dark red in color. Cannot emulate a real LED. Okay, so you can do that as well. In color cannot emulate a real LED. Okay, so you can do that as well. And off color in cold means you can probably use blue or green or whatever you feel like. So I can say on is going to be, I mean, light green, light yellow, light blue, and off color is going to be dark blue or something like that. It's totally up to you. Okay, this is too much, so what you can do is you can still decrease. So this is off, this is on. So now when I check it out, when the temperature exceeds certain value, the danger LED goes on, and when it goes up, it goes down, it's going to be normal, and when it goes below certain value, it says cold. Right? So these are some of the ways where you can program your lab code to achieve something. Right? So yeah. So I hope you understood what are the types of input and output, how you can start making decisions or conditions using a lab tool. Fine. Now let's go, before going into the decision making level, okay, let us come back to the pre-decision making level. Okay, now thing is you are able to visualize certain components of lab code. That is, there is a way to check whether it is danger, or check whether it is cold or not. Okay, you can also check whether it is in range. Okay, let's say you can have one more ready in between, which says it's normal. In between, which says it's normal. Okay, let's say you can have one more ready in between, which says it's normal. So normal in a sense, we know what is the greater than value, what is less than value. Okay, so whatever comes in between is going to be, normal value, right? So for that also you have functions. Okay, you can make those functions like you can check whether the value is both less than 225 and greater than 220. Okay, you can do that as well. But again, you have a certain function just for that, something called in-range checking function. Okay, you can use this to quickly solve the problem. So in in-range function, again, when I think I told you first day, if you want to know something about a particular function, you can press Ctrl and H together, and you can find yourself there. Okay, something called context help will open when you press Ctrl and H together. And what will happen here is you can check whether any value is in between the given value or not. Okay, you can give the upper limit, you can give the lower limit, and you can give the actual value also. So this value will be compared with the upper value, and it will say, okay, whether it's in range or it is not in range. Okay, so you can read about this function in detail also, and possibly also have some examples also. Okay. The reason behind this function is, let's say you're going to use something like speed control of a motor. Okay, so for speed control of a motor, let's say your maximum speed should be 300, 3000 RPM, and minimum delivery speed should be, let's say, 0 RPM, okay, of course. So now the problem will be, your motor it's possible to generate 4000 and 5000 RPM as well. Okay, but the speed it should be fixed, it should be at, let's say, 3000 only. In that case, when someone is trying to force those data to 4000 and 5000 RPM, this function what it does is, it will coerce the data to the maximum limit. Okay, when you say 3000 is the maximum limit, it will be 3000 only. When it is 100 is the minimum limit, 100 only should be the minimum limit. Okay, it's not go below. So in order to check these data out, this function will be used. Okay. So what I'll do is this thermometer value I'll give in between, and the upper limit for this is going to be 225. I'll check it here, and minimum is going to be 20. And to check whether it's in range or not, I'll connect in between. Okay, also I can choose to include the upper limit and lower limit as well. That is, meaning if you want to include this 225 or not, if you want to include this 20 or not. Okay, if I don't include this upper limit, it will consider only below 225. Okay, 225 will not be included at all. Okay, include lower limit, this 225 also will be included, 20 also will be included. Okay, so if I use this, you can see that 225 is also included. Okay, in the comparison. So let's just try it out. Right now, if you see it's cold, I'll increase the temperature. Right now it's normal. And let's say the boiler starts running. And normally there will be compressor in the boiler which will maintain the temperature at a particular pace. But let's say all this problem happens and the temperature skyrockets above, the temperature rises above the limit. Okay, so not only are you able to program the behavior, but also you are able to create the GUI. Okay, so that's where the strength of LabVIEW comes into play. And of course, this can be implemented in your hardware as well, because when we talked about, I also showed you the video that you can simply integrate LabVIEW to hardware. Okay, that anyway we will have a separate session for that. But if you see, there is a separate tool called measurement IO, and there are many hardware which will be available, which can be easily used to interact with certain hardware. And instead of this simulated thermometer, I can choose to connect that hardware to actual temperature measurement sensor and get the data inside here, and I can make the same GUI here as well. Okay, so when you say temperature, when you say sensor, you can say it can be a thermocouple, it can be a normal a PTC sensor, right? RTD, a thermistor, right? So right now, since you're still just simulating this effects, fine. And the program for it will be looking like this. Okay, it's actually a block diagram only. It's actually a flowchart. Meaning it says get the temperature data, check whether the value is greater than 225. If it is greater than 225, switch on the danger light, and check whether the temperature is less than 20. If the temperature is less than 20, switch on the cold light, else switch off. Also check whether the temperature value is in between the 225 and 20. Okay, it's in range or not. If it is in range, just tell us it is normal or not. So I hope everyone understood today's session. As always, today's session will be available for next 1.5 hours. So if you want to work out, you can actually play this video again, and we'll go through it. You can actually check. You can actually come back and check out certain aspects and check it out. Right? So if you have any queries, please reach us